Okay, so we have the function which says let fx equals to x squared by 2 when x is lying between 0 to 1, and that is 0 to 1, it is open at 1, and 2x squared minus 3x plus 3 by 2 when it is lying between 1 to 2. Clear? And you have to find out the continuity of f dash and f double dash on 0 to 2. Okay, now about the continuity of fx, okay, that is just f, how will you go about? Well, this is the number line, okay, 0 1 2 0 1 2. okay, I have to check the continuity of this f at 0 2, and I'll be probably checking this at the turning point, okay, that is at 1. So what I'll be doing is that if I move here, it means it is a left hand limit, and if I move to the right side of 1, it is a right hand limit. Okay, that is when x is less than 1, it is a left hand limit, and when x is greater than 1, it is a right hand limit. So you have your x squared by 2 as the left hand limit. Okay, so limit of x tends to 1, x squared by 2, this is no indeterminate form, it will be just 1 by 2. And similarly you have your limit of x tends to 1 plus, I should write the 1 minus, where it is 2x square minus 3x plus 3 by 2. Okay, so how do you go about it? You'll just substitute 1, so it is 2 into 1 square minus 3 into 1 plus 3 by 2. Okay, so it is 2 minus 3 plus 3 by 2, which is minus 1 plus 3 by 2, which is 1 by 2. Okay, and remember this, that this is equal to 1 for this particular function. Okay, this is 1 less than equal to x out here, and here it is just x which is less than 1. So when it is equal to 1, we are going to follow this part of the function. So value the function at 1 would also be equal to 1 by 2. Okay, because in case if I am going to put 1 here, so this will be 1 by 2. So your left hand limit is equal to right hand limit is equal to the value of the function at 1, which is equal to half. So it means that fx is continuous everywhere. Clear? Now we'll straight away go to f dash x. So what is the derivative of x squared by 2? Just x. Okay, this remains same, and it is 2x squared minus 3x plus 3 by 2. So what is the derivative of 2x squared minus 3x plus 3 by 2 with respect to x? It is 4x minus 3. Okay, so this is your f dash x. Okay, f dash x. Clear? Now we need to find out the continuity of f dash x. Okay, so how do we go about? It will be like this. I'm sorry, this should be less than 1 here, and it is equal to here. Okay, yeah, so f of 1 plus, that is a right hand limit. Right hand limit means what? Your right hand limit would mean this, your 4x minus 3, this part. Okay, that is your, when x is actually greater than 1, it is at this point, 4x minus 3, and I have just substituted 1 out here. It is 4 into 1 minus 3, which is equal to 1. For left hand limit, you have x which is less than 1, okay, and it is just this, okay, which is x, and I'm going to substitute my 1 out here. It'll be, left hand limit would be equal to 1. Clear? So I'm again going to write this for you guys. That is, your f dash x is equal to x, 4x minus 3, 0 is less than equal to x is less than equal to 2. This is my f dash x's. This is my right hand limit when x is greater than 1. Okay, so I'm going to substitute just 1 out here and I'll be getting 1. Okay, this is my left hand limit. Okay, so I'll just substitute 1. So x equals to 1 out here and I'll get this. Clear? And the value of the function at 1 would be also this, that is 4 into 1 minus 3, because this is also taking care of x equals to 1. So you have your left hand limit is equal to right hand limit is equal to the value of the function, that is your f dash 1 is also equals to 1. So it means this, that f dash x is also continuous at x equals to 1. And also, since this derivative is available, so you can say this, that f is differentiable. Okay, now what about f double dash? Okay, now I had this function with me. Remember this, that I had f dash x is equal to x and 4x minus 3. This is when 0 is less than equal to x is less than 1, and this is when 1 is less than equal to x is less than equal to 2. Okay, now my f double dash x would be what? Okay, what would be my f double dash x? This should be 1. Okay, well, this should be 1, I'm sorry. Okay, and this is 4. Okay, so what I've done is that I have derivated it once again. So x with respect to x will give you 1, and 4x minus 3's derivative is 4. Okay, now the point is that if you're going to see, then this is also discontinuous at x equals to 1. I'm sorry, there are certain mistakes. At x equals to 1, this is discontinuous. Okay, that is when for this is your left hand limit. This is your left hand limit. Okay, so this is my f double dash x. Okay, now if I'm going to put left hand limit here, nothing is going to change, and this will be 1. My right hand limit, that is your limit of x tends to 1 plus f double dash x, is 4. There is no x out here, so it doesn't matter. So it means this, that your left hand limit is not equal to your right hand limit. So it means that this function is discontinuous at x equals to 1. Okay, so what do you mean by this? That is, function is continuous, f is continuous, f dash is continuous, but f double dash is not continuous in this interval. Okay, thanks.